நினைக்கிறேன் சார். ஒன்லி 7 days, இன்னும் 5 days ரிமைனிங் இருக்கு சார்.
அதுக்கு தான் பார்த்தீங்கன்னா ஒரு ஆப்ஷன் சொன்னேன், என்னன்னா டேட் ப்ரீவியஸ் டேட் வச்சுட்டு ரன் பண்ணலாம், ஒர்க் ஆகும், நாட் அ ப்ராப்ளம்.
சார் இப்போ லேப்ல டேட் மாற்றணும்னா க்ரோம் ஒர்க் ஆகாதுல்ல சார்? மீட் எப்படி அட்டன் பண்ண?
அப்படியா?
ஆமாம் சார், டேட் அண்ட் டைம் கரெக்டாக இல்லாட்டி க்ரோம் ரெஸ்பாண்ட் பண்ணாது சார்.
சரி பார்ப்போம், அதுக்கு ஏதாவது நான் சொல்யூஷன் சொல்கிறேன்.
ஓகே சார்.
இன்னைக்கு ஒர்க் ஆகும், நோ ப்ராப்ளம்.
எஸ் சார், ஓகே சார்.
Okay, started recording this meeting. Okay, so once you have opened the Labview, the window will be displayed like this. Okay, in that, in file, create a new VI. Okay, either you can create a single file or you can create a project in which you will be able to manage several VI files as a whole. But basically, we are working with we are going to work with a very simple logic. So let us create a single file. File, create new VI. So once you have opened the Labview, two windows will be displayed. Left side is the front panel and another window is the block diagram. If by chance only one of the window is displayed, other is not available, you can select that and in the menu window, then show block diagram or show front panel. Okay. The front panel is mainly used for creating graphic user interface, and block diagram is where we develop our actual program. The program in Labview is basically graphical programming. That is, we do not write statements as in C or C++, but we connect blocks as per our desired logic. And in fact, it is a little bit easier when compared with C or C++. So let us directly move into the program. Okay, let us start with the basic fundamental program. That is adding or subtracting two numbers. Later we will move into our regular task. Right click in the front panel, right click numerical control. Okay, if you select numerical control, a widget will be displayed. You can change the label as per your wish. Let me put it yes. Let me create another numeric control. I'll rename it as Y. For displaying the output, we have to choose right click numeric indicator. Let it be. If you right click under numeric, different types of control and indicators are available, but programming context are the same. But when you are developing a complex application, the graphical user interface, these kinds of things may be a little bit helpful. Okay, but in programming context, all are same. Once you have created a block in front panel, if it has something related with programming, then corresponding block will be available in block diagram also. And you can see that these blocks are in orange color. Orange color represents floating kind of data, and even the data type will also be available at the end of the block. Here the data type is DBL. DBL stands for double precision data type. If you right click any block, there is an option called representation. There you can change the data type. Labview supports different kinds of data types. By default, most of the blocks will be double, and it also supports integer, single byte integer, 2 byte, 3, 4 byte, 8 byte integer, etc. Even unseen integers are also supported, and even complex numbers are also supported directly. Okay. So as you create a number 1, you can also create a complex number 1 plus j1. Let us add these two numbers and store the result in Z. How to create a program? Just right click under programming, numeric palette will be there. You choose add, left click on the add and move to the desired location. Once again left click. Add block will be available. Next we need to interconnect these blocks. Okay. For interconnection, you can choose. If you move the mouse to the terminal of each block, automatically the mouse mode will change. Okay, by default, mouse mode will be automatic. That is where you click that determines the operation of the mouse. But if required, if you feel it is little bit difficult, you can change any specific mode. For that, you need to press Shift and right click. If you right click, you can choose any specific mode. By default, the top row, that is green color, will be displayed, that is automatic mode. You can disable it. Once you click on it, it will get disabled. Then you can choose any mode of your liking. Okay. It is just convenience. If you are not comfortable with automatic mode, you can choose the specific modes. Just a shift right click and then you can choose whether select mode or wiring mode, etc. Wiring mode means interconnection. And if you press the next option, it is text mode. It is used to type some text in the program. So I am very much familiar with auto mode, so let me choose auto mode. Okay, it is enabled. Okay. So now we have created a program. We have interconnected the blocks. How to run the program in the toolbox? The first button will be run button. If you click on it, the program will be executed only once. And next button will be run continuously. If you click on it, the program will be repeated continuously, so that for a user it will seem like it is running continuously. To enter some values and the results will be displayed. 10 plus 10, 20. Okay, the program is working fine. There is nothing big about this program. It is a very basic program. Okay, so let us stop this program here. How to stop this program? The third option, third button, that is abort execution, is there. You can click on it and you can stop it. Next we move into for loop. Let me delete these blocks. How to create for loop? In the block diagram, right click, structures, for loop. Once you have selected it, left click and drag a box, leave the mouse. You will have your rectangle, and whatever you put within this rectangle will be repeated for n number of times. This for loop is equivalent to following syntax, that is for I is equal to 0, I equal to 0, I less than n, I plus plus. And in C language, whatever you put within the braces will be iterated n number of times. In the same way, whatever you put within this block will be iterated n number of times, where n is the loop count that you can tell externally. Let me create a control for it. Okay, either you can create control directly in the front panel, or another convenient way is you can right click a terminal and select create control. But only thing is it will be placed randomly somewhere. We need to properly adjust it in front panel. We have selected n. So just let us consider the iterating variable I itself, and that we will display in the output. I have clicked on it, and another click is in the end of the for loop, and once again right click, create indicator. Indicator is the output. Let me extend this array. Let the loop count be 5. If I run the program, what happens is the iterator output, that value is being fed to the output, and by default what for loop does is it will collect the output of all the iterations, and it will be displayed, that is it will be pushed as a single array. This is the nature of for loop by default. You can even change this option. At the end of the for loop, at the terminal of for loop, there will be a small box called auto indexed tunnel. You can right click on it, and under tunnel mode you can change different options. I leave it to you for your exploration. Nothing is very big or specific about it. You can choose different kinds of modes. But anyway, typically we do not use it. Okay. For loop in the same way. What we require is something called shift register. Now we will come back to the first part of our program, that is calculation of sum of n numbers. If we are to develop a C program for it, we will be developing like this. That is sum is equal to 0. For I equal to 0, I less than or equal to n I plus plus. And within the for loop, we will evaluate sum is equal to sum plus I. So this is a sample program for evaluating summation of n number. The idea is n is fed into the program, and we need to evaluate 1 plus 2 plus 3 plus and so on till n. That is our objective. That is summation of I is equal to 1 to n I. This is the output we require. Even you can add 0, that is not going to affect the sum. This is what we require. So for that, the C program will be like this, the core part of the program. If you are to develop this program in Labview, we have to create a for loop like this. Let us feed n externally. And another point to note here is this part. That is, we have initialized the sum equal to 0. This value is initial output. And after that, this left hand side is the sum of or output of present iteration. Here in the right hand side sum is output of previous iteration. Okay, so the present iteration output is dependent on output of previous iteration. So in order to facilitate this, Labview support an option called shift register. So just right click on for loop and the end of the for loop and select add shift register. Okay, two small blocks will be displayed both in the right and left. Okay, whatever you give in the right hand side, that will be available in the next iteration in the left hand side. So let us create the summation of n numbers. As a first step, connect the output. Okay, that is our sum of present iteration. As per our logic, sum of present iteration is sum of previous iteration. That is whatever you have taken from left hand side plus another number. That is our iterator. And as per our program, initially we have put the sum value as 0. This you can put it in the left hand side. The left hand side, right click, create a constant, that value is 0. Let us display the result. In the right hand side, create indicator. Indicator is the output. Let us rename it as sum. If I give 10, answer should be 55. 10 into 11 by 2, which is 55. But we only get 45. The reason is the Labview for loop will not support this less than or equal to condition. It is not supported. Okay. So what we are going to do is we change the program a little bit. That is, rather than telling less than or equal to, let me compare with less than n plus 1 I plus 2. That means my n condition has to be added with plus 1 for this program. Don't take it universal. For this particular program, we need to add the end value plus 1. If we do like that, then our problem will be solved. Add create constant, this value is 1. If we run the program, for 10 it is 55. If I enter 11, answer should be 60. Yes, it is working fine. So this is the program for calculation of n numbers. Okay, so this is the first task of Labview. So through this we have learned how to create a for loop, how to create a shift register, and how to evaluate summations. Throughout electrical engineering, we will be, for measurements, we require integration, and in discrete time it will be basically summation. So for that we typically require for loops. Okay. The second task, I'll quickly give a demo. You try it later. Evaluation of some complex number expression. Second task is this. Evaluate summation of I is equal to 0 to n I plus j I whole square. Here j is root of -1, your complex number indicator. How to evaluate it? The point to note here is Labview supports complex number as a basic data type, so processing them is easier. Basically the same kind of logic. That is, if you are writing C kind of program, not exactly C, I don't think C supports complex directly. Maybe latest version may support. I am not familiar about it. Initially, we might declare sum equal to 0 plus j0, and within the for loop, that is for I is equal to 0, I less than n plus 1, as I said earlier. Rather than comparing equal to n, we put less than n plus 1, I plus plus, and within the braces, we evaluate this. Sum is equal to sum plus I plus ji whole square. This is the logic. Similar program I'll develop here itself. The same for loop, let me develop. Let us add, for this present output depends on previous output, so we add a shift register. Left view the output, only then data type will be present output equal to previous output plus.
Excuse me, sir.
Yes.
Sir, there is some delay in
Yes.
the screen sharing, sir.
Okay, what can I do? இதுவும் வாய்ஸுக்கும் இதுக்கும் மேட்ச் ஆகலையா ஸ்க்ரீனுக்கும்?
எஸ் சார், மேட்ச் ஆகல சார்.
Yes, sir.
Sir, go a little bit slow, sir. We couldn't able to get what you are saying, sir.
Okay. 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 So our objective here is to evaluate this expression I equal to 0 to n, I plus ji whole square, where j is the complex number indicator, that is root of -1. So don't confuse with I and j. Typically in electrical engineering, we prefer j rather than I for complex number. Okay. So for this also, the expression evaluation is like previous case only, but only thing is we have complex number, that's all. And the Labview supports complex number by default. You don't have to make anything special. So let me, so for creating initial value, let me click on left side of shift register, create a constant, and this constant is going to be a complex constant. So right click that constant, representation, it is complex W. So once you have chosen, this particular data will be complex. Next, what is our expression? That is sum equal to sum plus I plus ji whole square. I is your iterating variable. Okay. I is directly available, then we need to create a complex number, that is I plus ji. Real part is also I, imaginary part is also I. Under numeric, add. Under numeric, you select complex, and in complex, you have some option, that is real, imaginary to complex. Select this block. Real part is also I, imaginary part is also I. And our objective is to square this. So under numeric, square options will be available. See, all these blocks are polymorphic. Based on the data type, whatever is available in input, their operation will vary. If you pass an array, elements will be squared. If you pass a matrix, then matrix square will be evaluated. So these operations are polymorphic. It's a very high level programming language. Okay, you can work as if you are thinking. In the output, create indicator. This is our task 2. So let me rename it as sum 2. So the result will be purely imaginary because we are taking square, and I know that. So this is the solution. This is the second task of our experiment. Okay. Shall I stop here, and do you need to practice it, or shall I directly move to the next program? It is your choice. Shall I move to the next program, or shall I stop here?
Sir, we will practice something, sir.
Okay. So now time is 2:41. Okay, I give you 20 minutes. Okay, even 30 minutes. Okay. So exactly at 3:10, I'll come back. We'll move to the next two set of programs. Let me stop recording, and let us see who gets the record.